Welcome to Methamphetamine. Today we're gonna do two questions, and the first one to show that the integral of f of x over x squared dx is equal to the integral of f prime x over x dx minus f of x over x without using integration by part. So to do the first question, like that, without using integration by part, let me consider f of x over x here. F of x over x is what? We know that integral and derivative, they cancel each other out, right? So why don't we just do a derivative? First we do a derivative, like f of x over x and then prime. It means the derivative and then do integral at the same time. So this and this, they cancel each other out. The integral and derivative, they cancel each other out. So it wouldn't change the original question. So here's the deal. The question says we can use integration by part, but we can use product rule in our derivative, right? So this is just, first you square that x squared and then x times the derivative of f of x is the symbol of this f prime x, and then we're gonna subtract f of x multiplied by the derivative of this is just 1, so never mind dx. So over, you can split it to two fractions and then x over x squared, you get f prime of x over x dx, and then minus the integral of f of x over x squared dx, like that. Okay, don't you know the subject is f of x over x squared? Let me move it to the left hand side. You get the integral of f of x over x squared dx is equal to this integral of f prime x over x. And then move the f of x over x to right hand side. You get this minus f of x over x, like that. This is the proof. You can also do it by using the integration by part. You will also get this, but the original question says we cannot use integration by part, right? So here's the deal. Yes. So session 2 is I found what? Here are the graph of y is equal to ci of x. And ci of x is called the cosine integral, and this graph looks like this. When x is approaches to 0, is approaching negative infinity, right? When x is approaching infinity, it goes smaller and smaller. It's approaching 0, like that. And the cosine integral, the input, it cannot be a negative number, otherwise you get imaginary numbers. So here is the graph of ci of x. In the real world, we pretty much just have the graph like this. So another one is y is equal to sin x over x squared. It's like this, the graph. Like that too. When x is approaching to positive infinity, is approaches to infinity is 0, right? When x is approaching to negative infinity, this is just 0. And then when x is approaching to 0, you see this negative infinity, right? Or positive infinity. Check the graph of this. When x is approached, but this is not the main point of this video, but I still gonna talk about. When limit at x approaching to 0 plus, 0 plus is just a number that's really closer than 0, a positive number. A bigger number than 0 is closer than 0, like that. Check the graph of this. It's approaching to positive infinity, right? When limit at x approaching to 0 minus of this, you see this is approaching to negative infinity, like that. here's the deal. Given the integral of cosine x over x is equal to ci of x. I forget plus c, sorry. Is equal to ci of x plus c. And then we need to calculate the integral of sin x over x squared going from pi to infinity. What's the areas we're gonna find here? So here's the graph. I'm going to show you. The graph, the area we're gonna find is this. And this, and then infinity. Goes from infinity. Why? Why this is a lower limit? Check the original graph. If you plus 0, you know sine 0. And then sine n pi, whereas n is for all integer, right? Sine x is equal to 0, and then x need to be n pi, whereas n are for all integer, you get a 0. And here is we know the lower limit, it should be x, the x-intercept, right? So we want the y is equal to 0. So the first one, when x is equal to 0, put it inside. You see over 0, you see we do not have the answers. And the second one, 1 pi. X is equal to 1 pi, you get 0 like that. So 1 pi, you pretty much this just pi, right? And you see this is pretty much just 2 pi like that. Because 2 pi, sine 2 pi is 0, you get the x-intercept is 0. So from pi to infinity like that. So we're gonna calculate this integral. Sin x over x squared dx. Here's the deal. I'm not going to let f of x is equal to this. Let me just do this really quick. Just use this identity we have proved. So you get f of x is this over x squared. You pretty much just have integral of, let me just write as sin x and then the derivative of x. This is the derivative symbol, dx, and then minus sin x over x, just x. But don't forget about the lower limit and upper limit. And then plug it inside like that. So over, this is the derivative of sin x is just cosine x. Cosine x over x dx. From going from pi to positive infinity, and then this is just, here's the deal. We're going to do some limit right now. So subtract. When you put infinity, sine infinity is an indeterminate form. And then over infinity. So indeterminate form, so we have to do more. So let me do it right here. Limit at x approaching infinity, sine x over x. And okay, here is the deal. We do not need to check the graph of it. And we cannot use the last video rule here, right? Limit at x approaching to 0 and then infinity, you still cannot use the last video rule. If you use the last video rule, you see what happened. Limit as x approaching to cosine x like that. So cosine infinity is still an indeterminate form. So we don't have any function left, right? So does this mean this function, this limit does not exist? The answer is no. You cannot use the last video rule on sin x over x. So x approaching to infinity, sin x over x. Here's the deal. Whenever you put an x into sin x, when x is an extremely big number like that, it's always gonna be between -1 and 1. So when a number divided by infinity, because sin x is way smaller than x, so over a really small number divided by an extremely big number, so over this limit you will get 0 like that. Another one, put pi into it, sin pi is just 0, and then 0 over pi you just get 0 as well, so minus 0 like that. So over the integral of cosine x over x is given ci of x, right? So over you get ci of x from pi to infinity. Good. So over what is ci of? Let me just put it first. Ci of infinity minus ci of pi, like that. So what is ci of infinity? If you are not sure about what is the graph of ci of infinity, check it out. Ci of infinity, you see ci of 0 is approaching to negative infinity, right? And then it cannot be a negative number inside. And then second one, when x is approaching to infinity like that, you see the graph is really closer to be 0 like that. So over ci of infinity, let me tell you this, just 0. And then ci of pi, just leave it, ci of pi, like that. So over the answers of this is just negative ci of pi, like this. This is really cool. Negative ci of pi. Let me check the answers of Wolfram Alpha. You see, negative ci of pi is about negative 0.0736679. Yes. Here's the area of this. It's equal to negative ci of pi. You see, the area is under the x-axis, so it's negative is true, right? Negative ci of pi.